Welcome to Homework Lib.
So here we have the following expression for acceleration in a device, which is given by mass 1 minus m2 over mass 1 plus m2 times the value for gravity. And we want to know what is going to be the uncertainty. So for that, we're going to calculate that the uncertainty for any function that is going to be function of a plus b, this is going to be the uncertainty associated to f squared would be equal to the uncertainty of a squared plus the uncertainty of b squared. This is going to be equal for both of the cases with the plus or for the minus. Now, whenever we have a quotient or a ratio of a over b, the uncertainty of f squared divided by f squared is going to be equal to the uncertainty of a over a squared plus the uncertainty of b over b squared. So over here in our function, essentially what happens is that a is going to be equal to m1 minus m2 in a ratio, and b is going to be equal to m1 plus m2. So the uncertainty associated to a is going to be equal to the uncertainty of mass 1 plus the uncertainty of mass 2. Both of them are going to be squared and taking the square root. The uncertainty for b, it turns out that is going to be exactly the same value as follows. So in our case, our function is going to be equal to ay. So the uncertainty associated to this acceleration on the y-axis squared over the acceleration on the y-axis squared is going to be equal to, according to the equation rule, the uncertainty of a squared over the value for a. Uncertainty of a squared is going to be equal to u m1 squared plus u m2 squared divided by m1 plus m2, the value that you got from your measurement, plus this is going to be the first term, and notice that m1 plus m2 needs to be squared as well, plus the uncertainty of m1 squared plus uncertainty of m2 squared divided by mass 1 minus m2 squared. So in this way, you can find what is going to be the value for the uncertainty. Directly, we can calculate the uncertainty of ay, and this is going to be equal, after we have taken the square root of the value of the solution on y, times all of this factor taken as a square root. Let's factorize the u m1 squared plus u m2 squared, and we get 1 over m1 plus m2 squared plus 1 over m1 minus m2, and all of this is squared. Remember, this guy's squared like this, okay? And we need to take the square root of all of this part of the measurement. So all of this to the 1/2. And this guy is also in parentheses to avoid any possible confusion. So this is going to be the value for the uncertainty. This is how they're going to calculate it. Of course, over here I'm considering that in our function g is going to be a constant with no uncertainty whatsoever, as it is indicated. So you just need to replace the value that you got from your experiments. Remember that the uncertainty of each of the masses may be coming from the resolution of your measuring device, or it may come from the standard deviation. Just over here, a small correction. This needs to be also an absolute value of the function. Okay, here I was just assuming that was going to be positive. So with that, it would be all. Thank you very much and have a good one.